In this video, we're going to try to factor some problems where the trig functions are not matching. So before I go ahead and solve these extra practice problems, I want you to pause the video and try to solve them on your own. Alright, so let's go ahead and solve these. So the first thing I notice is that these trig functions are not the same. And so because of that, I need to convert one of them. So we're going to write down an identity. So recall that sine squared plus cosine squared equals 1. So sine squared is going to be equal to 1 minus cosine squared. So then I get 1 minus cosine of x is equal to 2 parentheses 1 minus cosine squared. So again, the sine squared goes in, and a 1 minus cosine squared comes out. Now if you'll notice, everything is in terms of cosine. So that's what I want. So then I get 1 minus cosine of x is equal to 2 minus 2 cosine squared of x. And at this point, I'm going to go ahead and move everything to one side. So I'm going to add the plus 2 cosine squared of x and minus 2 from both sides. So then I get 2 cosine squared of x minus cosine of x minus 1 is equal to 0. Then I'm going to do my little trick where I let u equal cosine of x. So I get 2u squared minus u minus 1 is equal to 0. Now this becomes much easier to factor, and I get 2u plus 1 times u minus 1 is equal to 0. So when I set both of these equal to 0, I'm going to get u is equal to negative 1/2 and u is equal to 1. Now I have to put the cosine back in for u. So I get cosine of x is equal to negative 1/2 and cosine of x is equal to 1. And cosine of x equals negative 1/2 when x is 2 pi over 3 and 4 pi over 3. And cosine of x is equal to 1 when x is 0 and 2 pi. But remember, we cannot use the 2 pi because it's not in the interval bracket 0 to 2 pi with a parenthesis. Remember, the parenthesis means it's not included. So my final answer is 0, 2 pi over 3, and 4 pi over 3. So looking at this problem now, sine squared minus sine of x plus 1 equals cosine squared of x. You see we have a trig function squared twice. So the question is, which one do we change? Well, the key is to look at the one that's not squared. So the one that's not squared is sine of x. That means I'm going to want everything in terms of sine of x. So using our identities, I'm going to rewrite this as sine squared of x minus sine of x plus 1 is equal to 1 minus sine squared. So again, this cosine squared became 1 minus sine squared using our identities. So my next step is to get everything on one side. So I'm going to subtract 1 from both sides and add sine squared to both sides. And I'm going to get 2 sine squared minus sine is equal to 0. And in this case, it's like in a problem we did a long time ago, where you only have two terms and they have something in common. So they both have a sine of x in common. So I can factor that out. And I get sine of x times 2 sine of x minus 1 is equal to 0. So then using my zero product property, I set both of these equal to 0. 2 sine of x minus 1 equals 0. I'm going to solve this one to get sine of x by itself, and I get sine of x is 1/2. And then sine of x is equal to 0 at 0 and pi, and sine of x is equal to 1/2 at pi over 6 and 5 pi over 6. So putting them all together, you get x equals 0, pi over 6, 5 pi over 6, and pi.